Okay, so you had this kind of idea for, it's a medical device. It needs to have like a textured surface. I would show the image here, but it's on my phone. An image, or like little metal balls on the surface. And the idea that you'd had was to create like a volume surrounding this and scatter within that. And you can do that. The way that I would approach this is I would take, for example, if this was my geometry, and I'm going to do some things that don't match what you're going to do because you're going to have more control. Hopefully you have a better model. But I'm going to take this and I'm going to say normal. So I'm going to put normals on this. Right? So that way I've got normals coming off of that. Then I'll go ahead and let's just do a scatter. And we could paint on this if it was higher resolution to say, this is my density map, but I'm not going to worry about that right now. I'm just going to kind of do this. I'm going to say group. And you can see that these have already picked up the normals, and they're already kind of blended. So they're not, just straight off of what it was, but, like off of a face, for example. It's kind of blending between those different normals to give us something that should feel smooth. And I think that'll work, maybe. We'll see. So I'm just going to take this grouping, we're going to make this points, we'll say keep, I'm going to say bound in region, box is fine, that box is a little big, so we're going to use our selector tool here. Normally I would do this with more kind of a procedural way of handling this, but for now we're going to be really handsy. Really handsy. Alright, so we're going to delete, non-selected, keep, points. Alright, so that gives us just kind of what's on the handle. Alright, I'm going to turn off my normals. And right now I'm going to keep them kind of laid out like this. They're fairly regular, and that's fine. And I'm going to use a point replicate. I really love this node. And we're going to come here and add some attributes to these points to kind of help us control this. But for now, we're going to use the point replicate. We'll make this just 10. The shape for now, what I'm going to use is going to be a disk or a circle. And if we shrink this down and make this like 0.1, making more 0.01, we kind of see these little circles. And you see that right now it's kind of following what's happening. And I would say that's more or less what I want. We might want to go back and kind of do these and figure out the normals that it's picking up, how to sharpen those, because it's blending across them. So we could either do that by up-resing, right? So if we were to take this tube and we were to, say, subdivide this. Right? And we're going to just keep the crease nice and hot. Right. And I could have probably done the same with up here. If I like where this is, but I'm not getting enough vertical columns, I could always reset to 3, maybe 4, 5. So we're starting to get closer to nice little squares. There we go. Maybe something like that. Just all depends on what you're trying to do. So now if we come back to our scatter, point replicate. There you go. Those follow the surface a little bit better. And then the cool thing with this is that little disc shape, we can then use this to like kind of fill up our first level, and then we can start adding on to those. And I'll kind of show you what I'm thinking here. So if we take our original scatter here and we just increase, right, we'll start to get something that feels like it's covering a lot more of what we had. And for visualization, I'm going to use a copy to points. The first thing I always do is turn on pack and instance so I don't crash my machine. Put down a sphere. And we'll plug that into the geometry to copy, and this is going to go into our points. And obviously those are huge, so we're going to put 0, 0, 1, so they're little tiny points. And so we start to get something that's kind of built up. And we'll see that all of these right now are sitting on that first plane, right? That kind of that first level. We've got a couple of them that are lingering over from the edges, but that's probably okay. Now we can either take this and we can increase how many points are in our point replicate, so we don't have to necessarily keep adding more. We can come in here and say make that 100. This is gonna get heavy for a second, but then all of a sudden we've got a lot more points on our surface, to the point where the GPU doesn't quite want to draw it. Most likely these are all so crammed in here that we've got probably points kind of sitting on top of each other. So let's go back to maybe 20 of these, and we're just going to kind of keep increasing this here to start, because I think that'll maybe get us something a little bit better distribution. I'm also going to come into my little sphere here, and I'm going to reduce this. We're going to make this 6 and 8, and that'll reduce the draw burden because they're small. We don't need that much detail. So now all of these are kind of the same size, which is probably what would be happening in your little tool. But now we want to kind of add some additional distance to these. So one of the things that we could do is, if you want this to feel, we could just take and now do another layer, right, of this and push them out along the normal. So we could use Vex to do this, but we'll use an attribute VOP for now, because I don't know, not everybody loves Vex. So I'm going to throw this down here. And based on the normal, I'll just put down a displace node. So displace along normal. Oops, sorry. Displace along normal. If I can type. Use position. This is where we're going to use the normal, so that's fine. We'll just output back out to position. And then for this, I usually just like to take this and say right click, actions, no, sorry, parameters, where does that live? I do mostly with Vex now, so I forget. Create input parameters, is that it? That is. So now we're going to come up a level, and now it's like a little tool. I don't have to keep jumping down in there. So with this, we can take a look at these points. We can take this and just push it out along that normal. So, you know, as we displace, they get further away. So we kind of get to decide how far we want to do that. Now at this point replicate, we can also take this now and say make that 10. And then we're going to just merge together our 2 points. And now we'll switch that out. So all of a sudden you've got something that is starting to give you that sense of depth that I think you were kind of looking for. We might be getting a little kind of weird at the edges there, so that might be something to work out, or going back to what you're doing before. The other thing that we might consider doing is this, is taking these, instead of making the shape a circle, we could do these as a sphere, and so that'll give us a little bit more of a kind of an even distribution. We can then decide how big we want those spheres to be, how much coverage they are, but now we're looking to say, okay, well, we're inside of our tool, but that's not a problem because we can go and say group, and we can group these based on our original geometry. So I'm just going to break off a little dot here to make it easier. I'm going to alt left click, give myself a little spine here to travel with, and we're going to say points. And we're going to say remove. And we're going to come down here to turn off this enable. And bounding regions, we'll say bounding object. And it's going to bound what's inside of that geo, which is fantastic. And then we'll just put down a delete. And so now we've got something that's going to stay on the surface there. And so this now becomes pretty easy to control, right? It gives us kind of the ability to determine how much is in those, how much coverage we have. You can have more or less. Ideally, I think you want it to feel like these things are always connected and you don't have any like little free floating little spheres. And so, you know, we can either do that by increasing the number of points that we're scattering. We also could take this whole setup here that we have, copy and paste this, take our global seed and change it, and then when we plug this in, it's going to shift some stuff around, just give a little more variation so it's not the exact same as what was in there before. Now, what you can also do for animating is you can take those points and then apply a random attribute to those and then animate them on that same normal vector. Because if we take a look at the normals, we still have normals off of this, right? So we'll display our normals. Oh, it didn't inherit, sorry. So we're gonna come down here to our point replicate, and we're just gonna go to attributes and say copy source attributes. That's gonna pick up the normals now. Give that a second. Well, it's got normals. Last thing is come over here and turn off, delete this little excluder, and now it'll inherit the normal as well from, well, it should have, oh, it's probably because it's packed. It's putting the normal on the geometry itself, which is fine. We don't really care about this picking up the normal, to be honest with you, because that doesn't matter. So you're gonna use it here. So you would do like an attribute VOP. And we would do like an attribute randomize. So you do an attribute randomize. So, sorry, I'll do it. Integer. Attribute integer adjust. And I could use this to create like a start frame. So we'll set initial, and we'll do random, and it gives me a min and a max. So if I were to look at this, I could bring up this attribute that it creates, variant. Fine, we'll keep that. I don't really care what it's named. It's whatever makes the most sense to you. But there, so now we've got these variations, and that could be the start of when you want it to animate, like the frame you want it to begin moving on. You could use that to drive it. You could also use this for like its starting distance, right? So, you know, maybe we make this 1 and 9. And so then I would come here and you can say displace along normal. And for the amount, we could bind and bring in our variant, which is technically an integer. And it was, we'll do a divide node, and we'll put down a parameter for the constant. And then this parameter div by, none of that matters. I'll come up here and we're going to say 9 because that was how many we put here, right? We could connect these or whatever we want. And variant, is there a integer to float? Integer to float. So that now will give us maybe our scale. And we can promote this, promote parameter, and now we can take that and you'll see that those kind of move out. And then you could animate this, right? So you can have this on like a time scale so they come in. And you can come up with all kinds of fun ways to drive this and make it, you know, so it's doing what you want. Then we come here, put our little spears on it, we zoom out, and let's say $F. So we'll say fit. Actually, we'll say smooth. $F. And we'll say $F start. $F and okay, cool. So that's going to give us 0 to 1 with a nice fall off, and I don't ever keyframe anything. And then I'm going to say fit that, and we'll say 0 and 1 because that's what's coming in, and I'll say 0 and actually I'm going to make this 0.1 and 0. So now you get a little stepping because we used an integer. We could use that as a float, and that'll get rid of that steppiness as our amount, but this kind of gives you the idea. So as this moves, it's going to start animating. Right? So you can see it's got to ease in, ease out because of that smooth, and that'll start bringing all those little spheres in. So let's say we don't want to use this as an integer, so let's do a float adjust. And not p-scale, we're going to use, we'll just keep variant, because that's what the other one was. Set initial, I'm going to set this to random. It gives us a min and a max. I think we're doing 1 to 9, so let's stick with that, 1 to 9. And now we have a ramp that we can kind of adjust where those kind of fall. Oops. So already you see that it kind of smoothed out those edges, right? Got rid of the, it didn't get rid of the banding because I think I still have this set as an integer. We'll make that a float. We're going to get rid of that node. There we go. And that softens things out. And now we can come into this little guy here and maybe make some adjustments. We could take this and say, let's make you round. Is that what I want? Yes. So then you'll have fewer kind of out and about, and most of them are already kind of where they're supposed to land. You could even make this min value as 0, and then ideally you've got some that are starting already on the machine. It's however you want to make the animation look pretty. But now you've got this kind of cool thing that's gonna, we'll flip book this real quick. See what it looks like. I apologize if there's any stutters in this or if it doesn't sound good. I do have a heavy render cooking in the background. Okay, so something like this where now everything kind of pulls back in. I don't love how it's kind of going straight in. I would probably go back to the more blended kind of normals. It'll kind of spread these things out and they'll feel a little more organic maybe. But in my mind, this kind of does what you're saying now. You were saying also that you wanted to get an attribute that represented the distance, right? So the ones that are further out from your object. So we can do that. Vex is probably the easiest way, but I'll try to do an attribute VOP. So this goes to using a VDB. So we're going to use a VDB from polygons. VDB convert, no, VDB from polygons. Right, it's going to be this guy here. And do that. So there it is. We're going to leave it as a surface. 0, 1, let's go 05. I want to have enough value. I'm going to go ahead and fill the internal, turn that on, fill interior, exterior band 10. So what this does is just gives me some range outside of my surface. So now I'll use an attribute VOP again. And I'm going to do this before the, let's do this as our first setup here. So here's all of our points. So I'm going to come here and we're going to say gradient, volume gradient. I hit enter every time. Volume gradient. And we'll do a volume sample. So what this does is the volume sample is going to tell us how far outside or inside of that surface we are, and the volume gradient is going to tell us what direction we are from within that. So we probably are going to be able to use just this. So instead of primitive number, well, we'll leave that what it is, file, we're going to say second input, and now that's going to pull from that VDB. Primitive number is 0 because there's only one volume, so that's the index number. That now is for sample position. We'll take our point position, and now let's just output that as CD for now. And you see it looks almost black because these are tiny values. So we'll do a fit range node, and we'll just put a tiny value on this, put a 1, something like that. So there now we're starting to have a range that we can map. So that's about as easy as it is. I can put that into color, or I can store it by saying bind export. I usually don't like to use color because it comes to bite you later if you're building a bigger tool. So we'll put this as, I don't know, outside in attribute, and then we'll just delete this here, and then we'll come out here to look at our, oh, didn't give it to me, so we're going to come here, hit the I button, and look at our outside in. And now it gives me purple. I can kind of see green. It goes to red, so it's a little easier to look at than the white. So now I can kind of find what this is. 05 maybe? There you go. So now I have a nice little 0 to 1 range based on distance. I can use this however I want now. I can use this as an attribute to drive our displacement. So we'll go back here to where everything's displaced. So now, before we were using this variant to kind of figure out the scale, now I can use a bind node, and let's use the outside in attribute. We'll use that. And so this is just going to give us some variation based on a random number, based on the p scale. So maybe I'll do this. Let's leave this as it was. What? And we'll just do a new one. A new one altogether. Outside in. We're going to do a random. And throw that down. This is going to give me a 0 to 1 value. Oops, and I don't want that off this. I'm going to say off of point num, not num point. So this will give me 0 to 1. I can remap this to whatever I want. But for right now, let's just say we're going to take this value and multiply it by our inside out. Let's see what this gives me for my scale. So now that's pushing things out, and anything that's a 1 is going to go out further. So the stuff that's like closer, this should kind of help you with like animation being appropriate as to when, right? So it doesn't feel like things are like cutting through itself. It'll give you a little bit better. Now, one of the things that I want to do is I want to actually change how I'm animating this. So instead of using this here, I want to use a value in here. Now I can't animate things inside of here. That's why you promote things out. I think there's a time. Oh, there's not. So we'll use a parameter to go fetch the time. So we're going to say time. And we'll call this $f. Now I can pass time into this. So for my amount, I'm going to double click that. That's that parameter that we made and we animated. I'm going to take this and I'm going to say smooth. This should give me the ability, so let's see, my range bottom, range top. So I should be able to put this in for amount. So my time needs to be remapped to a value. So we're going to say fit range, and we'll do another random here. And to get a seed for this, I'm going to just do an add node. And we're going to just trick it to think it's a different point number. So we'll say constant and bloop, bloop, bloop. There. Now that's a seed value. So that changes the randomization. And what we're going to do here is we're going to tell it how many, like what's the frame range duration that we want. So we'll plug this into the max. So the amount will be the time. The max will be the how fast this happens. So we're going to say this fit range, we're going to make it, let's make this, how many frames do we have here? We have 240. So we'll say 96 to 240. So this will cause some collisions in our animation that we just kind of fixed, but that's fine. And for our amount is going to be time. We want this to be a 0 to 1, so we're going to just go ahead and divide time by our last frame. So we'll put down a constant. Our last frame is 240. This may freak out on the first frame because it won't return a 0 value. And then we'll put a fit range on this. This is how we're going to be able to control now the magnitude. We've kind of got the timing of it. And let's see. Let's look at this. That's our smooth, our start and our end. 0.1 was our magnitude. So we'll take our 1 and make it 0.1. And this becomes our new amount. Maybe. It might not evaluate while we're inside. Let's see. No. Are you evaluating? You are. So if this is time constant, let's do this. To check it, I'll throw it into color here. Come out. We're going to turn off our little inside out. There you go. All right, that's doing what we want it to do. Now, let's see what color looks like after we smooth that out. So this might be 0 all the time, which it is. And we saw this animating, so the amount should be rolling off between those two. Range top. Let's take a look at what that looks like. And 96 to 240. So let's not use color for that. Let's output this as test, right? So we go bind, export, call this test, and we'll come out, we'll turn on the test, and it's all red because we want to come here and say test attribute. We're going to edit that, and we're going to say its min was 96 and its max was 240. Okay, so that's working. Okay, that's what we would expect. And so this is animating. That's giving us our min and our max. Oh, I think we needed to reverse this for 1.1 and 0. Okay, that's good. Test this, and we'll edit this, and this is going to be 0 to 1. Okay, that's doing what it's supposed to do as far as time goes. Okay, now our test should be smooth, should give us 0 to 1. And it's only giving us 0. So So what we're going to do is we're going to break our connection here for time. Okay. Let's break our max connection here. Okay, so it's expecting 0 to 1. What if we make this 240? Oh, okay. Fair enough. So, maybe we stick with our random and we're going to make this 0.5 to 1. Let's see if that gives us a better result. Well, there you go. So that's animating, and not everything's happening at the same time. So the idea behind this is it gives us like a variation in speed, right? So not everything is moving at the exact same speed. And kind of get some ones that lag behind. Okay, great. That was the idea. That was the idea. So now we can come turn off our test attribute. I could delete that because I really don't need this. So I'm just going to disconnect it. And so I don't want to create a lot of extra junk on my points. So I don't really need that variant anymore either. I think we kind of stopped using that. So again, I can just disable that. Make sure that I have the littlest possible. And then I would delete those attributes once I'm done. And I don't need them. But now, shame that I moved my camera. But we should be able to see variation in that animation. Oh, what happened? I broke something. I'm looking at the wrong thing. No? Silly me. I had forgotten I disconnected my animation there, so I just disconnected the thing that was driving the anim, which is fine. So now I don't love this kind of little gap that creates, and that's fine. We can now really easily go back and just forget the subdivide there. And so now we can see that it kind of smooths that out a little bit, so we get kind of a more of an interesting blend between those. And because we're using the spheres instead of the disks, it's still going to come back to a nice little finishing point there. Let me save this real quick, make sure I don't crash out. Alright, so I went back and I upped the number of points a little bit. I shrunk down the size of the, so I increased the number of scattered points to 7,500. And then on the point replicate, I increased the quantity to 15 on our kind of outer points and to 30 on our inner points. And then I took the shape of that scatter and I decreased that to 0.005. You could introduce some noise to try to break those up, but it's the same across every point. The only way that this makes sense is to then go and randomize like the orientation on the point. So, for example, if we were to add this this simplex noise, let's see. You don't really visualize much of anything. You might start seeing a pattern. If you wanted to get rid of that pattern before this goes in, and I would do it before animation probably as well. I would, right in here, I would come in and I would do a attribute randomize, I think is the one that I want. Yeah, and I would just say N, and instead of uniform, I would make this direction or orientation. And now this is just gonna, it's just gonna randomize the normal of all of these spheres, so how they get scattered on. Now, when we do that, so if we do that here, what's going to happen when we animate our points is we're going to get some that go inside, right? So you can see that they're kind of going in all directions here, because what we've done is we went from our source points having a normal that pointed out to now they're pointed kind of all over, right? And we can come in here and change the global or whatever, but this gives us the ability to have some randomization. So what we need to do before we do this is we need to do an attribute create, I think is how it would be the easiest. I would normally just do all of this in one big wrangle, but so we're going to call this new normal, NN is usually what I do. Size of this is going to be 3, and the default is going to be 0, and the values we're going to say at n dot x, at n dot y, and at n dot z. Okay, so now we've stashed the normals into a kind of a new spot. So, and this doesn't go here. This is the wrong place to do all this. This needs to happen, so we're gonna have to do this twice. This needs to happen up here for the point replicate. Okay, so we'll do that. Copy and paste this guy over here. Do it again. Clean up that, or I'd make this a little easier to follow. So now, when we look at our point replicate, you see that just the normals are kind of all over. This will help give us some randomization to how we perceive the noise that we've added. But now we want to put our old normals back. So we can just use attribute vop. Let's do a wrangle here because wrangles are so nice. They just are so nice. And I'm going to say at n equals at n. Oh. This should have carried that across. So let's look what happened here. So we're going to look at NN. And we're going to come here and we're going to edit that. Instead of a color, we're going to make it a marker. Instead of text, we're going to make this a vector. Great. Length scale 0.1. All right, so that's what I would expect. So when we switch this to n, right, and we pick up our new normal, that should have fixed that. Hold on. Oh, it most likely, it's just we need to do that. So we need to tell it it's a vector. So there we go. So that fixes it. Copy, paste, plop one down there, just ploop it on in there. And then ideally, we don't need that new normal anymore, so we're going to say delete. Oh, sorry, attribute delete. And we can go in and kind of start cleaning this up. I'll do it after here. So I just have to do it once. And we don't need that new normal. And so now we can come back over here, turn this off. A second to calculate. And there's our spheres are doing what we would expect. We can take a look again at this and look down the middle, and you'll see that we're not flying into the middle anymore. So we've been able to kind of preserve that animation that we were using before. But now, ideally, when we get to the end, we should be able to see a little more organic kind of noise pattern. Nothing repetitious. It should feel nice and randomized, which it does, to me, anyway. You do get a couple little points that are not connected here every now and again. The key to that is to make sure your p-scale is big enough that they're always kind of touching and connecting, so we could go back in and just adjust the size of our sphere, make it a little bigger, and then ideally when it comes to rest, they're always touching. Now, that feels too big to me. But again, it's just a matter of kind of finding the values in here of what's going to make the most sense. So, but yeah, so that should give you some attributes to play with, some ways to animate, and kind of have that follow. Again, using something that maybe feels like you have a little bit more control. You kind of have two layers of points. So that way you can have some that are on the outside that maybe are a little bit less. We could have done that also with pushing those out and using disks for that outer part, so you have breakup, so it's not volume and things don't feel like they're floating. But I think from this distance you're probably going to be okay. Everything's going to feel all right. So give that a try.